Hello, everyone. This lecture is about predictive analytics by machine learning. Missing data typology. Chapter 4, Section 3, Exploring Missing Data Patterns. Handling missing data is an important step in data cleaning. If missing data is not handled properly, it can lead to bias, reduce the efficiency of algorithms, and lead to incorrect conclusions. This section details the types of mechanisms by which missing data can occur. There are three types of mechanisms through which missing data occurs. MCAR, missing completely at random. MAR, missing at random. MNAR, missing not at random. In practice, it is common to process missing data assuming it is MAR. But strictly speaking, different processing is required for each mechanism. Therefore, it is important to understand each mechanism. I will explain each of these in detail below. MCAR is an abbreviation for missing completely at random. MCAR represents the assumption that there's no particular trend or regularity in the missing data, and that the missing data occurred completely by chance. To express it more formally, if the missing data is independent of the observed data and unobserved data, it is considered MCAR. An example of MCAR is a case where, in an online survey, some respondents have internet problems and so do not respond. In such a case, missing data occurs due to chance, regardless of the characteristics of the respondents or their response tendencies. If this assumption holds, there is no bias caused by the missing data when processing the missing data. In other words, it can be assumed that there is no difference in any trend between the data that is missing and the data that is not missing. Therefore, there is no problem with processing the data by excluding cases with missing data, that is, by using a simple method such as list-wise deletion. However, in actual data, the MCAR assumption is rarely satisfied, so careful judgment is required. MAR is an abbreviation for missing at random. Missing at random is the assumption that the reason for missing data is not dependent on the missing data itself, but on other observed data. In other words, it refers to cases where information from other observed variables can explain the missing data. For example, suppose data on annual income is missing in a survey. In that case, the missing data is related to observed variables such as age and education level, but is not dependent on the missing annual income data itself. In other words, the missing annual income is predictable based on the person's age and education level, but is not dependent on the actual value of the missing annual income. MNAR is an abbreviation for missing not at random. MNAR refers to mechanisms where the missing values occur in a way that is dependent on the data itself. In MNAR, the occurrence of missing values in a variable is not random. Rather, the variable itself is one of the causes of the missing data. For example, if a survey contains many missing values in income data, some respondents might avoid answering because their income is too high. That is, what is meant by the missing data is one of the causes of the missing data. Let's focus on the difference between MAR and MCAR. The difference between MAR and MCAR is in what the occurrence of missing data depends on. MCAR assumes that the occurrence of missing data is completely random and does not depend on either observed or missing data. For example, MCAR is a case where some survey respondents had a problem with their internet connection and were unable to complete the survey. MAR, on the other hand, is an assumption that the occurrence of missing data depends on other observed data, but not on the missing data itself. For example, MAR is a case in which annual income data is missing, but we can predict missing data based on other information, such as observed age and education level. In summary, MCAR assumes that the occurrence of missing data occurs completely by chance, independent of either the observed data or the missing data. Meanwhile, MAR assumes that the occurrence of missing data depends on other observed data, and not on the missing data itself. Next, let's clarify the difference between MAR and MNAR. MAR is the assumption that the cause of the missing data is related to other observed data, but not related to the missing data itself. On the other hand, MNAR is an assumption that the cause of the missing data is related to the variable that includes the missing data, and that the information hidden by the missing data is the cause of the missing data. An example of MAR would be a survey of annual income data, where the annual income data is missing based on other information such as age and gender. For example, young people and women are more likely not to report their annual income, but the annual income itself is not the cause of the missing data. The missing annual income data is dependent on other variables such as age and gender, but not on the annual income itself. An example of MNAR is when a person with a high income does not report their income to protect their privacy. In this case, the reason for the missing income data is that the person has a high income. In other words, the missing income itself is the cause of the missing data. If there are missing values in a dataset, there are methods for filling them with estimated values. This is called missing value imputation, and by filling in the missing values, we can restore the integrity of the data and improve our prediction model's performance. MCAR, MAR, and MNAR are different mechanisms through which missing data occurs. This difference requires different approaches for missing value imputation for each mechanism. In subsequent sections, we will explain missing value imputation in detail, but here I will give a brief outline. In MCAR, missing values occur completely randomly, and there's no bias in the overall data. In MCAR, missing values are not dependent on other variables or data itself, so it is assumed that the missing values will not differ significantly from the average trend of the data. Therefore, we can use simple methods such as imputing the missing values with representative values like the mean and median. For the same reason, in cases of MCAR, we can also use a listwise deletion, which means deleting rows that contain missing data. In MAR, the occurrence of missing values in one variable is dependent on another variable. Therefore, we can impute missing data using the information of the variables that affect the occurrence of missing values. Specifically, we can use multiple imputation and regression imputation. These are methods of estimating the actual values of missing values using other observed variables. In MNAR, the missing data itself is the cause of the missing data. In MNAR, missing data occurrence is not random. So, imputation with the mean or median is inappropriate. In addition, since MNAR is not related to other variables, we cannot estimate the value using information from other variables. Therefore, we can use advanced methods such as expert-based imputation and sensitivity analysis. As you have seen, the processing method depends on whether the missing value is of the MCAR, MAR, or MNAR. Therefore, strictly speaking, we need to identify the type of missing value before carrying out the imputation. We should determine whether missing data is MCAR, MAR, and MNAR according to the following steps. First, test whether the missing data is MCAR or not. Here, we can use Little's MCAR test. If the MCAR test result shows that it is not MCAR, then examine the possibility of MAR. Here, we use correlation analysis or logistic regression to examine whether other observable variables are affecting the missing data. If the results indicate that it is highly likely that the data is not MAR, then examine whether it is MNAR. As there is no robust statistical test for determining whether missing data is MNAR, we use sensitivity analysis and make inferences based on expert knowledge. Let me give you a detailed explanation of how to check whether missing values are MCAR. We can use Little's MCAR test to determine whether the data is MCAR or not statistically. This test evaluates the missing data pattern and determines whether the assumption that missing data is MCAR is correct. The steps for Little's MCAR test are as follows. First, we set up a null hypothesis and an alternative hypothesis. The null hypothesis is that the missing data are completely randomly generated. The alternative hypothesis is that the missing data are not random, but occur according to some regularity or relationship. Next, divide the data. Specifically, divide each variable into missing data and non-missing data. In other words, we divide them into two groups, the missing group and the observed group. Then, calculate the means and covariances of these groups. Then, perform a chi-square test. In this chi-square, we statistically test whether there is a difference between the observed data and the missing data. If the missing data are MCAR, the difference between observed data and missing data is not statistically significant. If the missing data are not MCAR, there will be a significant difference between the observed data and the missing data. We can determine statistical significance based on the p-value. The p-value is calculated using the chi-square statistic. If we set the significance level to 5%, 0.05 or higher p-value is considered that there is no statistically significant difference between the observed data and missing data. This indicates that the missing data occurred randomly, so the MCAR assumption or null hypothesis cannot be rejected. In other words, the missing data is considered to be completely random. On the other hand, a lower than 0.05 p-value indicates that the observed data and the missing data are statistically different, so the MCAR assumption is rejected. In other words, the null hypothesis is rejected and the alternative hypothesis is accepted. In this case, the missing data are not MCAR, but are occurring according to some regularity or relationship. In other words, the missing data are likely MAR or MNAR. Little's MCAR test is suitable for evaluating whether the MCAR assumption holds for the entire dataset, as it can verify the randomness of missing values for multiple variables. However, it cannot directly distinguish between MAR and MNAR. It only verifies whether the MCAR assumption holds. In addition, it may be difficult to make a precise judgment in cases where the data structure is complex. The chi-square test is based on the assumption that the data is normally distributed. So, if the data distribution is asymmetric or there are many outliers, the value of the chi-square tends to be large, and the null hypothesis is more likely to be rejected. Moreover, if the cause of the missing value is due to complex interactions between multiple variables, there is a limit to the extent to which the MCAR test can fully capture the complex effects. In the case of MAR, the occurrence of missing values is dependent on other observable variables. Therefore, we can use correlation analysis and logistic regression analysis to verify other variables' impact on the missing data. Correlation analysis can check the correlation between the variable containing the missing data and other variables. If the variable containing the missing data strongly correlates with other variables, the missing data is likely MAR rather than MCAR. Logistic regression, which uses whether data is missing or observed as a dependent variable, can identify other variables that affect whether or not the data is missing. If one or more other variables significantly affect the probability of missing data, it is likely that the missing data is MAR. MNAR is difficult to identify because the missing data itself causes the missing data. However, we can use the following approaches to explore the possibility of MNAR. The first is to make an inference based on expertise. Since there is no statistical test to directly determine MNAR, expertise about the data and its context is critical. For example, a labor economics expert can infer that the person with a high income is more likely not to report income. We can also use sensitivity analysis. Sensitivity analysis is a way to explore the possibility of MNAR by setting up multiple scenarios regarding missing data completion, evaluating the model, and examining if the results vary significantly across scenarios. Let me explain the procedure of sensitivity analysis. First, set up multiple completion scenarios. For example, in scenario 1, the missing data are complemented, assuming extreme cases such as being biased toward the minimum or maximum value. In scenario 2, missing values are complemented with the mean or median of the data, or by regression completion based on other variables. In scenario 3, missing data are complemented with the most conservative assumptions. For example, set the missing values extremely low or high. After setting the scenarios, complement the data based on each scenario, build a predictive model, and evaluate the predictive performance. Then, if the results do not differ significantly between scenarios, it is assumed that the completion method does not have a significant impact on the model. In this case, the missing mechanism is most likely MAR or MCAR. On the other hand, if the completion method changes the results significantly, it indicates that the variable containing the missing data is itself affecting the missing values. This suggests a high likelihood of MNAR. In practice, it is often difficult to precisely determine whether missing data is MCAR, MAR, or MNAR. While MCAR and MAR can be somewhat discerned by statistical verification using Little's MCAR test, MNAR is difficult to identify directly. Therefore, it is common to proceed with data preprocessing, assuming that the missing data follows the MAR assumption. This is because imputation methods based on the MAR assumptions are often accurate enough even when the missing data are MCAR. MAR assumption is more flexible and it can handle more realistic cases than MCAR. Therefore, in practice, we often regard the missing values as MARs without strictly distinguish the missing value types. If it is evident that the data is MNAR, we should remove the variable from the dataset or take measures to minimize its impact. Thank you for watching. Please thumbs up and subscribe to my channel.